Okay. We are originally given that AC is parallel to BD. I automatically think that if I'm given that lines are parallel, that means that those we can only find information about angles here. So we haven't been given any information about side lengths, which is fine because we have a similarity criterion that proves that triangles are similar with that. We want to prove that AO times DO is equal to BO times CO. That's a weird thing. I may not know exactly where I'm going with that, but I do know I'm going to prove those triangles are similar. Let's get some crazy fun colors. I'm then going to prove, I could do vertical angles here, but I'm feeling a little bit, I'm not going to say lazy, I'm going to say resourceful. I know that I'll only have to do one statement if I want to use alternate interior angles to prove that two sets of angles are equal, and I won't even have to say anything about vertical angles. So we're going to label that 1 and 2 and 3 and 4. I can say that angles 1 and 2 and 3 and 4 are equal to each other. Alternate interior angles are equal. Okay, I've said that two sets of angles here are equal, which means I can prove that those triangles are similar. Triangle AOC is similar to triangle BOD because of the angle similarity criterion. And then it starts talking about AO being multiplied by DO and BO being multiplied by CO. And I realize that I hate that I use that word all the time. I see that I am talking about multiplication here, and I know that what I know about side lengths is that their ratios are proportional. And if their ratios are proportional, that means I'm dealing with fractions or division, right? So I know that's going to be connected to that somehow. So I'm going to set up a relationship that involves those side lengths and see what happens from there. AO corresponds to BO and CO corresponds to DO. And those guys are proportional to each other because corresponding side lengths are proportional. Hopefully now you can see that if I multiply both sides by DO and I multiply both sides by BO, that I would get then my final statement. AO times DO equals BO times CO. And that's what we'll just call algebra. QED. Last proof for the day. We have two quadrilaterals that are similar, and the definition of similar holds true for no matter what shape it is. Any two shapes all corresponding angles are equal and all corresponding side lengths are proportional. I'm going to draw two quadrilaterals that look to be similar. It doesn't say that they're parallelograms. It could be anything kind of wonky. I'm going to label it, come on, A, B, C, D, A prime, B prime, C prime, D prime. Then the lengths of the corresponding diagonals are the same ratio. So I'm going to draw in a corresponding diagonal. Diagonal goes across a quadrilateral as the lengths of the corresponding sides. In other words, that the corresponding diagonals are proportional with the side lengths. I'm probably going to be proving that two triangles are similar, given that these two quadrilaterals are similar. I'm going to say A, B, C, D is similar to A prime, B prime, C prime, D prime. And I'm going to use the fact that they are similar in order to prove some pretty crucial parts here. I want to say that angle B and angle B prime are equal to each other. And I'm going to say that AB is similar to, or the ratio of AB over A prime B prime is equal to the ratio of BC over B prime C prime. And then I would be able to have side angle side between those two triangles. And then I would be able to say that AC over A prime C prime is proportional or equal to the ratio of BC over B prime C prime. That's the thought process. Almost always we're talking about triangles in all of our proofs. Angle B equals angle B prime. And then we're going to say that AB over A prime B prime is equal to BC over B prime C prime. Step 2 is because this is going to be a lot to write out. Corresponding angles of similar triangles are equal. Corresponding side lengths of similar triangles are proportional. Okay, now that I've said all of that, I can say that those two triangles are similar to each other. Triangle ABC is similar to triangle A prime B prime C prime, and that is our side angle side similarity criterion. And then now we can say that AC over A prime C prime is equal to AB over A prime B prime because corresponding side lengths of similar triangles are equal. No, proportional. Did I say equal above? No, okay. And we're done. So that's kind of your look into similar triangle proofs. Now that you feel comfortable with congruent triangle proofs, it's just kind of a different thought process than that. Just slightly, though. Okay, that's it for our notes. This is the last new thing you're going to be learning. We're going to take one day to kind of just practice a bunch of different proofs. And then 2 days of review, and then your test will be on the 14th.